Thank you very much for coming to the talk. So many familiar faces. It's good to be back at DeepSec. So AMSI or AMSI, it's the technology which comes built in Windows 10, integrated with Windows Defender, targeted against or to stop script-based attacks. And that's what I'm going to talk about today, what AMSI is, how good it is at detection, how does it improves the existing defense methodologies, and being a red teamer, of course, the ways how we can avoid or bypass it with lots of live demonstrations. Hope demo gods are happy with me. So, some shameless self-promotion. I am a penetration tester and trainer. You can follow me on Twitter. I say this every time when I speak in public forums. I'm a sucker for Twitter followers, so please do it. Please follow me on Twitter. I blog a lot. I blog on laborforpenetrationtester.com. I maintain 2 open source toolkits for red teams or penetration testers, Kautilya and Nishang. Kautilya is a toolkit which helps in using human interface devices, mostly tested on TNZ devices, which helps in creating ready-to-use sketches, which you can just burn on your device, attach the device to a machine, and you should get a shell or something interesting. Nishang is a toolkit which actually led me to do research on this topic. It is a collection of PowerShell scripts, once again for red teamers, which you can use in your penetration tests or security assessments. I've spoken at a couple of conferences previously as well. So what we are going to discuss is we'll see what script-based attacks are, just in case some of you have not used them. Then we'll see what AMSI is, how it improves on existing detection techniques, how it specifically targets script-based attacks. Then we'll see that there were some failed attempts to avoid detection. I tried some different methods which failed. Then we'll successfully bypass it, and that's it in the talk. So what are script-based attacks? PowerShell, VBScript, JScript. We will focus mostly on PowerShell. VBScript and JScript, those still widely used by attackers, both the good attackers and the bad attackers. VB and JScript, they are sort of things which, it's actually blasphemy to use VBScript if you have PowerShell available. So mostly we'll stick to PowerShell. Why we will stick to PowerShell, or why generally me or any penetration tester worth his or her salt should use PowerShell. If you do penetration test of a Windows-based network, even if it is not an Active Directory environment, once again, if you do penetration test of an Active Directory environment and still not using PowerShell, you're missing something really, really important, interesting, and useful. So why do we use it? First of all, low rate of detection, still true compared to binaries. You can easily check that with let's say, Mimikatz. How many of you know about Mimikatz? I think, okay. So it's a tool to extract interesting credentials, etc., from memory on a Windows machine. So you compare mimikatz.exe, the executable, and its PowerShell port, and you'll still know that the executable's detection rate is way, way higher than the script. So low rate of detection. Very effective. PowerShell provides you access to .NET, WMI, registry, Windows API on the local machine and on the remote machines as well. Of course, you have to have enough privileges to do that. So it is already present on the targets. Post Windows Vista, PowerShell comes pre-installed on all Windows machines. Yes, it is used by system administrators, provides access to a lot of things. And I think it's been just a couple of years since PowerShell scripts, even with those which are written on the disk, are detected by any antivirus. But nowadays, it's fairly common. So to avoid that, we execute scripts from memory. So there are basically 2 ways to execute PowerShell scripts on a target. The first and the lame one is to write or drop the script onto the disk and execute it from there, which is generally not recommended. The second way is to execute it from memory. There are 3 ways of doing that. We can classify it in 3 ways. The first one is encoded command. If you see the help of, so we basically stick to the built-in features. If we are using something like PowerShell, which is a built-in feature, it is always recommended to abuse features, live off the land, instead of trying to do something which may flag off any countermeasure. So if I list help of PowerShell.exe, you'll see there is an interesting option called encoded command. What this option does is whatever the script, or whatever the command you pass to it, it could be a single command or a script, that gets executed from memory, never touches disk. Second option is to use the net.webclient .NET class, which those of you who have used PowerShell previously must have used, that single line download cradle IEX, that is invoke expression, new object, net.webclient.download string. So that's the download cradle and URL to your script. What the download string does, as the name suggests, let me quickly show you that. So IEX stands for invoke expression. That's an alias for invoke expression. It, as the name suggests, it executes the whatever expression you pass to it. So this is a .NET library, assembly we're using, net.webclient, and its method download. So you can see that there is one download file, and there is download string. And here we pass the path to the URL where a PowerShell script resides. So as the name suggests, download string pulls your PowerShell script as a string in the memory of current PowerShell process and executes it, once again without touching disk. Another method, this one is actually quite widely used. And as far as I know, it is logged by Windows Management Framework 5 PowerShell autologging as suspicious activity. Nonetheless, so that's the second method. Third method is to reflectively load your PowerShell script in memory of PowerShell process or any other process. So you might have guessed that it is really easy to detect scripts which are saved to disk. But how would you detect scripts which are loaded in memory? And that's actually, that's been exploited so much that from Windows 10, there is a technology or a method which is enabled by default, coupled with Windows Defender, which is called AMSI, that is anti-malware scan interface. This, I think, has been stolen from its documentation. It provides file, memory, and stream scanning. So the stream scanning is the IEX thing, which we saw just now. Content source, URL IP reputation checks, and other techniques. It can be integrated in any application. As far as I know, right now, only Windows Defender and AVG are the only 2 antivirus solutions or anti-malware solutions which use it. So the third point, if you look at the slide, is quite interesting. Includes additional calls for scripts that use obfuscation or layer dynamic code evaluation. And this is what actually got me started to test AMSI. We'll see how effective that is actually. So this is the basic architecture of AMSI. Once again, I think taken from MSDN. Have I listed the source somewhere? No. Okay. So whenever you submit or a user submits a script for execution, as you can see here, different types of scripts, AMSI steps in just before the script code is submitted to the scripting host, just before execution. And then the code, the plain unobfuscated code, because a scripting engine cannot execute code which is obfuscated or encrypted or something. The clear plain text code is then passed on to the whatever antivirus is enabled on the machine, which in this diagram is Windows Defender here. Here, the third one, AV provider layer. and it gets evaluated against known signatures. So that's the basic idea how AMSI works. Note that when we discuss this diagram, the script is submitted just before execution to AMSI. That means whatever obfuscation is there would be stripped down from the script submitted to the scripting host. For example, let's say you use just base 64 encoding. Scripting host, if it does not understand base 64 encoding, just before getting submitted to it, the script will be converted back into the plain text and then submitted to it. Just before being executed by a script host, AMSI steps in and sends the script, the unobfuscated plain script, to the antivirus installed on the machine. That's one thing. Also, because we are working on the script host level, the method of execution, whether you type down a script, load it from disk, load it from memory, ultimately it needs to get to the script host level. And it is at that level when AMSI steps in. That also means that if this DLL or assembly, if someone recognizes this is something which can be used to execute PowerShell scripts and command without PowerShell.exe. PowerShell is nothing but a wrapper, sort of. So really insulting PowerShell. It is nothing but a wrapper around .NET classes. That's the basic reality of PowerShell. So even if you remove PowerShell.exe from your machines, and blue teamers or defenders, please make note, if you remove PowerShell.exe from all the machines in your environment, that makes no difference, just that it may be hard for you to detect any malicious activity, nothing more than that. So anyone can use this DLL or assembly, .NET assembly, to execute PowerShell code. But this assembly also needs the PowerShell scripting host, which is not PowerShell.exe, to execute scripts. That means even if you use this method, AMSI will still step in. So I actually found out AMSI first time when my scripts for Windows Defender started to mark my scripts from Nishang as malicious. And I was all the time loading the scripts in memory. In my lab testing for one of my trainings, I found out this thing. And that was actually quite catastrophic for me. PowerShell has been life-changing. Post-exploitation with PowerShell is really easy. So let's see how AMSI, oops. Just give me a sec. So what we are going to have a look right now is how AMSI detects things. And I just forgot to boot this one. So this is a Windows 10, I believe, updated to the latest, but its license is expired. But this is a valid evaluation version, so please don't think I pirated anything. So what we are going to have a look right now is this. We will first disable Windows Defender so that, okay, I'll just show you this. So here is a local web server which I started on my machine. So those of you who do not know it, this is invoke Mimikatz, the PowerShell port of mimikatz.exe, which is, I think, the most widely used PowerShell script by red teamers. You can use it to play with Windows credentials. Very interesting. Need to run it from elevated privileges to get anything interesting. So it is loaded on my host machine on a local web server. So let's see what happens without AMSI. I'm disabling AMSI. Is it visible? I don't think so. So simple command. We'll get back to this command. We just disabled, not AMSI actually, we disabled Windows Defender. And now let's pull, invoke mimikatz into the memory and execute it. There should be no detection actually because we've disabled Windows Defender. So there was no detection. We can now safely run invoke mimikatz, which should not produce any interesting results right now. We are not running it from an elevated shell. But the thing is, it gets loaded. Now let's enable or re-enable AMSI. And from a new PowerShell session, if I run the same command, okay, that was quite interesting. So, okay, apparently demo gods are not really happy. So there should be a detection actually. Let me quickly. I believe so. So, okay. Meanwhile, it satisfies its need. Oh, yes. Okay, we'll get back to that. We'll see that there is a detection, and it is quite easy to understand that that was because of AMSI actually. Now, how do we bypass this? That's the next question. As a red teamer and as a blue teamer as well, as soon as something blocks our way, we should try to use different things. So I tried a couple of interesting things which are really easy with PowerShell. One thing is to store a PowerShell script as a WMI namespace, because I've not seen even a single antivirus. Have any one of you seen any antivirus which scans WMI namespace for malicious things? I don't think so. So I tried that, no use. Because the script stored in WMI namespaces, that's fine. But as soon as it is pulled from the namespace, it is decoded and is executed. AMSI steps in, sends it to Windows Defender. Same goes with Windows registry. Encrypt a script, store it in Windows registry. As soon as it is pulled and decrypted, AMSI steps in. Same goes with event logs. Push a script in bits and chunks in event logs. Whenever you want to execute it, AMSI steps in and detects it. Nightmare. Okay. I think I'll just start another one. Now that was for unusual storage. When you store your script, not on the disk, not in the memory, but at different places. So Windows provides ample of opportunities to store your malicious script or shell code on a target machine. Then there is unusual execution. For example, tools like NPS, which, as we discussed, executes PowerShell scripts without PowerShell.exe. No use. Reflection, memory space of other processes, limited help, but that's noisy on some other level, so not useful. Then application whitelisting bypasses like install-util, regsrv32, rundll32, msbuild.exe, no use. Because in all these cases, no matter, as we discussed, no matter how your script was loaded or executed, as soon as it gets submitted to the scripting host, AMSI steps in and sends it to Windows Defender, which runs a scan or whatever it wants on the script. So up to this time, frankly, in my real penetration tests, if I found something like this, it's scary. It's really scary. You don't know anything about the target environment. This one. Okay. So let's try it once again. So we have turned it off on that machine. Let's try it without turning it off. Let's see what AMSI does. No, it's not going to shut down once again, I believe. That's fine. So, so you can see that the script has been downloaded, and just okay. So I believe there was a detection. Let's quickly see if there was a detection. So there is a prompt, there was a detection. Let's see what does it say. Is it visible? No. So you'll see that the last detection, the latest one for our script, was using AMSI. You can just tally the time as well. So which is quite interesting. Our script, which was not detected when AMSI was not in action, gets detected now. Now, are there any ways to avoid this thing? There are actually. We can use PowerShell version 2, which unfortunately for attackers is not possible on Windows 10 machines because it needs .NET 3.0, which is not present by default. But of course, you will find in enterprise deployments, you will always find .NET 3.0 enabled on Windows 10 machines. In those cases, you can simply run something like this, PowerShell v2, and this process which now gets started, this prompt is a PowerShell version 2, which does not communicate or does not support AMSI protocols, and you'll be good. But this is just one of the ways, not very interesting. You need to actually have .NET 3.0. Then interestingly, the second point, that is to change the signature of your scripts. This I found really interesting, because if you remember where we were discussing AMSI, MSDN documentation claims that if your script contains obfuscation, there are additional calls in AMSI to deobfuscate that or to analyze that script at a deeper level. But we'll see that not only significantly changing the signatures where AMSI or the AV steps in, changing the exact signature. If we can point out to the exact thing which they are looking for, that makes us a happy panda. We can actually bypass or avoid AMSI. Then, if you are in a destructive mode, you can actually disable it at all. So, signature bypass, obfuscation. It's not actually obfuscation, it's really lame thing which we are going to do now. We'll remove the help section, all the help commands. So what we are going to do now is, I'll take a script from my own toolkit which gets detected as malicious, and we'll remove it in bits and pieces, and we'll see that what is the actual thing which Windows Defender is looking for. So here is the thing. AMSI just submits your script to the antivirus product installed on your machine. Those antivirus products still plagued from that signature detection problem. If you can significantly change signature of your script, you're going to get passed through this thing. So what we are going to do right now on the script, we're going to remove the help section, obfuscate function and variable name, so just remove it. We'll encode some parts of the script, that's it. So you can do it manually if you have got all the time in the world. In a 5-day penetration test, best of luck and obfuscating your script manually. Then there are some interesting ways. This one is ISE steroids. That's really fast and really effective. And then this is invoke obfuscation by Daniel. So this is some crazy ass next level obfuscation. So just go for it if you're really into that. So let's see. Okay, so this is how obfuscation looks by ISE steroids. Okay. I just wish if that one comes online, that would be quite good. First of all, let's see what. So one of the script from Nishang, this one gets detected as malicious by Windows Defender. Whenever you load it into AMSI, so what we are going to do here is we will remove bits and pieces of the script and see what is the exact thing which AMSI or Windows Defender thinks is malicious. So let me quickly So now I am pulling this script. So now execution of this script has been stopped because this script contains malicious content and has been blocked by your antivirus software. Okay. Now let's try to see what this antivirus software. So once again, the job of AMSI here was to pass this script to Windows Defender. That's it. That's AMSI's focus is to provide the antivirus an overview or a view of what a script contains. AMSI itself is not a detection product. It just helps antivirus to look inside what a script loaded in memory has or may have. So let me quickly remove the comments from here. And I believe actually that I need to remove the whole functionality as well. And let's see if the detection is not there now, if it can actually bypass the things. So no. So one thing is busted here, that it is not actually in this case this is not a behavioral detection, because we are not doing anything here, just declaring a function and some parameters. So let's change the name of these things as well. So now if I quickly remove this thing, let's see if it gets detected now. No, it doesn't. So that means it was just a signature based detection. AMSI passed on the script to Windows Defender, which was looking for specific function names or specific parameter names. That's it. That means better obfuscation may work as well. So what do I mean by better obfuscation? It's this. So there is this one. If you have a look at this, invoke mimikatz obfuscated. Let me just open this. So this is invoke mimikatz with obfuscation from ISE steroids, and it is this. As you can see that it was lying there on the disk of the machine and was still not detected. And even if I run this, the invoke mimic gets obfuscated, it gets loaded, and if I can just make out the function name from here, it may be possible to execute it as well. So that's the function name here. So for better results, you can always include the function call in the script itself, so you need not look for something like this and then execute it. So this was ISC steroids obfuscation. You can see that AMSI is silent, Windows Defender is silent, obfuscation is still there. Then there are, and this is I'm not going to show you because I think I'm running out of time. This is obfuscation by the invoke obfuscate by Daniel. So once again, you can see that this is quite visible. What type of obfuscation is there? Much more interesting than what ISC steroids does. Once again, no detection by AMSI. So this is how we can use obfuscation to avoid AMSI. Then there are ways of unloading AMSI. We can use this PowerShell commandlet set MP preference, which we saw already. One, to disable Windows Defender already. If you use this, disable real-time monitoring, you will see that a notification is shown to the user. It needs elevated privileges, and then there would be a Windows event log 5001 and Windows Defender operational. That real-time disabling, real-time monitoring has been disabled. You can also use, this is the one which we use, disable IOAV protection. If we disable that, once again needs elevated privileges, but there is no notification, but a Windows log as well. Then a really interesting way of unloading AMSI that was tweeted by Matt Graber, the guy who wrote PowerSploit, another very good PowerShell tool. So you can use this command actually to unload AMSI from current process. No need of elevated privileges, but once again, event ID 4104 gets created. If you use this value, the one down here, this disables script block logging as well, but there is still a log which says script block logging was disabled, which is kind of not very constructive. And there is another publicly known method of unloading AMSI that's discovered by Cornelis, the guy who wrote PoundShell. That's actually PowerShell.exe looks for AMSI.dll in its current working directory, the classic DLL hijacking method. What this method does, it copies PowerShell.exe to a current working directory, whatever directory you are executing PoundShell from. It copies PowerShell.exe to there, drops a fake AMSI.dll, which gets loaded and gets unloaded, and that's it. There is no AMSI, bye-bye. So let me quickly show you very quickly. Okay, so okay, you can see that there is an AMSI.dll here already. And let's just load Mimikatz. I select the option 4. And there will be no detection actually here. But there will still be logs because there are so many offensive PowerShell scripts which are loaded in memory that they will create these logs, suspicious script block logging. So another quick demo, quick. So let's try to see everyone's favorite Meterpreter. Can we get a Meterpreter on a Windows 10 machine with AMSI turned on? We should, I think so. So I'm starting a listener here, and what I'm going to do here is this. Okay. So actually have this one ready here already, just tested it in the morning. So I'm not going to generate the doc file again. So this one is really interesting because now we are doing it from a client-side attack, no administrative privileges required, nothing special required, just that a client will open our malicious attachment, and that's it. So yeah, I believe I am. Yep. So we have a listener here, and as soon as the client opens up, yeah, please go ahead, open up, and says enable content. We should have a listener here. Come on. Okay, I think. So it pulls down the script. I'll show you maybe after the talk what it actually does. It pulls down the MSF payload.ps1 from the Kali box and executes it in memory. That's what it does. And we have a connect back from that Windows 10 box, which is quite interesting. No detection, no pop-up, nothing. And we are the lab user which executed the script. So if you notice that one thing which still came in between us and unhindered PowerShell code execution was Windows Management Framework 5 auto-logging. You can see that it is not possible, as far as I know, if you use PowerShell. And in fact, there was an interesting blog by someone who works for MS that we promote you to use PowerShell. Now, I'm not talking about Lee Holmes or Jeffrey Snover, the guys who made PowerShell. They're very open to us bad guys using PowerShell. Someone wrote that we actually want you to use PowerShell for bad things because there is no way you will not leave a fingerprint. And that's quite true. Having used PowerShell for past 5 years for penetration testing, I can vouch for that. If you are running PowerShell version 5 and you are a defender or a blue teamer, please make sure that you do not disable PowerShell. I encourage the bad guys or the red teamers, whom you want to target, that they do use PowerShell. There is no way we will not leave any logs. We can't. It's not possible as far as I know. Just make sure that someone is monitoring the logs. So AMSI is really a big step forward, much improvement over. So Windows 7 actually just surrendered in front of PowerShell as far as security is concerned. Windows 10 fights back. And as we saw, it is not a silver bullet. Once again, AMSI is not a silver bullet. It is this easy to bypass or avoid it. But coupled with other defense technologies, and if someone is really looking at the logs, it could be really useful for defenses. So well, that is all. This is my information. You can contact me if you want. Thank you.
Thank you. Thanks for being on time, although the demo gods weren't with you all the time. But we will sacrifice a few lunch items afterwards, so maybe the afternoon will go better. Are there any questions? We still have a few minutes left for questions, so please do ask. Again, it's a great opportunity to ask questions without spending lots of money. Ottmar.
Is there any way Microsoft can fix this?
Oh, so not me, but a couple of guys reported their bypasses of AMSI to the MSRC, the Security Response Center of Microsoft. And like UAC, they do not consider this a security boundary. So no urgent fixes, but I believe I don't know, I mean, they will fix it. They are taking AMSI quite seriously. But because it is not a security boundary, no priority in fixing bypasses of it.
And as most corporate installations are still Windows 7, the computer lost on this, correct?
So yes, but you can always, if you run Windows 7, you can always update to WMF5, which will install PowerShell version 5 on your machine, and that will support AMSI. Question?
Is there a possibility to lock the plain text PowerShell script, all plain text PowerShell scripts over AMSI?
So what's that? Didn't get you?
Is there a possibility to lock the plain text PowerShell scripts, all PowerShell scripts which are executed over AMSI?
To block them?
Lock.
How do,
To lock.
log? Oh, that's my bad. Yes, yes. So PowerShell version 5, there is auto logging. So if your script performs something suspicious, it will be auto logged. If you want everything to be auto logged, there are two ways. WMF5 supports universal transcript. That is, whatever the PowerShell process runs, whatever the command is passed with, that is logged. That's one. Another is if you turn on process logging, that logs everything. Maybe you can just turn on process logging for PowerShell, cmd.exe, or few more executables. That will help as well. So if your script contains passwords in plain text, yes, they will be logged.